In this video we're going to look at solving quadratic inequalities, and there's an example of a quadratic inequality just here where we have an x squared, perhaps an x term, and perhaps a number in there, but instead of having an equal symbol we have the greater than or less than symbol between them. The steps are that we've got to try and get the whole thing to be to have 0 on one of the sides, right? So we're going to have to rearrange things so that it's less than 0 or more than 0, more than or equal to 0, less than or equal to 0. Then you take the left-hand side and factorize it, just as we did for equations. So we're treating them like equations, and then if you treat it like an equation, you'll find the solutions for that equation, for what would be an equation. Once you've found the solutions, you've got to determine whether the sign, if it's going to be positive or negative for each of the factors that we have on either side of the solutions, and also between the solutions. And then look at what you get when you multiply those positives and negatives, or whatever they might be, together. Now that might not make that much sense as it is, so let's look at the example 5 that we have here. We have an inequality, I should say. X squared plus 2x is more than or equal to 3. What we've got to do is, first of all, rewrite that so that it's x squared plus 2x minus 3 is bigger than or equal to 0. In other words, we've taken that 3 and we've shifted it over to the other side, or we've subtracted 3 from both sides of the inequality. Now, another way of writing x squared plus 2x minus 3 would be the way that you get if you factorize it. You think of what numbers multiply to give negative 3 and add to give positive 2. Well, can you think what they might be? There's positive 3 and negative 1, which would work if we did that. So when we factorize the x squared plus 2x minus 3, what we should get is x minus 1 times x plus 3, and that has to be bigger than or equal to 0. Now comes the difficult part. Now the solutions to the equation x minus 1 times x plus 3 is equal to 0 would be 1 and 3. And those are the numbers that we are going to place to say that there are roots, the solutions for the equation. Now what we need to do is to investigate what happens to x minus 1 times x plus 3 over to the left of negative 3. So for examples like negative 4, negative 5, negative 6, is it going to be positive or negative? Between negative 3 and 1, is this thing going to be positive or negative? And over here to the right of 1, so examples like 2, 3, 4, 5, 6, is it going to be positive or negative to the right of that? Is this going to be positive or negative for values of x bigger than 1? And here's one way to do that. You take the roots, so the factors, the factors being x minus 1 and x plus 3, and you investigate if they're going to be positive or negative, for example, to the left of negative 3. To the left of negative 3, what can you say about x minus 1? X minus 1, for any values of x less than negative 3, x minus 1 is going to be negative. When it is actually, well, and then if you try again negative 3 itself in x minus 1, negative 3 minus 1 is going to be negative also. If you try a value that's between negative 3 and 1, for example 0, and put it into x minus 1, 0 minus 1 is going to be negative. If you try 1 in x minus 1, 1 minus 1 is 0. And if you try any number that's bigger than 1 in x minus 1, so for example, if you try 5 in x minus 1, what you should get by doing that is a positive. And you do the same thing for x plus 3. Right? X plus 3, any value of x that is less than negative 3, if you put it into x plus 3, so for example, if you try negative 5 and put it in place of x here, what you should get when you do that is a negative number. When you try negative 3 plus 3 is 0. If you try a value that's between negative 3 and 1, so for example, if you try x equals 0, 0 plus 3 is a positive number, so that means that we have a positive for that root between negative 3 and 1. X equals 1 is going to give us 1 plus 3, a positive value, and any value that's bigger than 1 is also going to give us a positive value. And then look at what happens when we multiply x minus 1 times x plus 3, because that's actually what we're interested in. We want to know, does it give you a positive value? We're interested in when this thing is positive, when it's bigger than 0. So, if we multiply a negative times a negative, what we get is a positive. If we multiply negative times 0, well, any number times 0 is going to give us 0. If we multiply a negative times a plus, we're going to get a negative times a plus is going to give us a negative. If we do 0 times any positive number, 0 times anything, again, is going to be 0. And if we do a positive times a positive, then what we get when we do that is a positive. So, looking at what we have down here, can you see where the x minus 1 times x plus 3 would be positive? It's going to be here and it's going to be here. So the solutions are x is less than or equal to 3 because the whole thing is positive over here, or x is bigger than or equal to 1 because because this whole expression here was positive to the right of 1. Now that's one way of doing it. It's a little bit quicker to do it in this second method. So I'll show you the second method straight off. Again, you need to put the roots in as best you can. So you put negative 3 and 1 down, and you just, in one go, just do a calculation for what x minus 1 times x plus 3 would be. So x minus, to the left of negative 3, it's going to be negative times a negative. That's going to be a positive. For negative 3 itself, the whole thing is going to be 0, so it's going to be 0. Between negative 3 and 1, if you put in, for example, a value of 0 in for x, we'll have a negative times a positive. And if you do that, what you should get is a negative. For 1, we're going to end up with 0, and any value that's to the right of 1 is going to be a positive times a positive, because if we plug in any value of 1, any value bigger than 1 into this equation here, for example, if you put in 2 here, we'll have a positive times a positive, and what we should get if we do that is a positive. Again, we've got a positive over here, a positive over here, and we've got a positive over here, giving us these solutions.